Okay, if you're just joining us, we just talked about number 31, boundaries. You can look through slowly, pause. There you go. Okay, so anything else about 31? 31 wasn't too bad. I know 31 was maybe the easiest, but this gives us the structure. Okay, so let's cut ahead to this one. This one was nice. It was just a little bit lengthy because there's 4 boundaries, and here you have the 4. Just let's identify. I won't do this one unless someone really wants me to. You have the 4 boundaries, y equals 3. Here, this boundary is y is equal to 0. This boundary is x equals 2. And this one over here is x equals 0. So you have 4 corner points, potentially 4 or more boundary critical points, and then there would be 1 critical point in the region. Maybe. I don't know. Let's see, what is the region? It's going to be 1, 1. Oh, yeah, that's in the region, isn't it? So the critical point in the region is the point 1, 1. So did anyone have anything that you're like, or maybe you didn't do it, and you're like, I don't know what to ask, but anything that was problematic about this? One of the nice things about this, so despite the fact that there are a lot of boundaries, is that they're all constants, unlike the one up top. So you just plug that constant in, and essentially you don't care about that term now. Like when I plug, I could tell you, I'll tell you exactly where all the critical points are. You have the critical point in the region, 1, 1, and then there's going to be a critical point on each boundary. There they are. At the point 1 in the boundary. Because there's no mixed terms here, that's the way it always works out. But you can do the math and figure it out. So you'll have, what is that, 9 points to plug in, all with integers. So not terrible, but it is lengthy. It is time consuming. So I felt bad when I saw that, when I realized that I was a little bit more optimistic than I should have been when I made this assignment. Okay, let's go on. Let's take a look at this one. So this one was fun because of that curved portion. So notice that the region, we're talking about these numbers that are in the first quadrant. That's what the x greater than 0 and y is greater than or equal to 0 means. There's 3 obvious corner points. And then this is the only one that's a little bit weird. That is the curve x squared plus y squared is equal to 3. That's, by the way, a square root of 3 is the radius. So the way I would do this, the way I would evaluate that, I think the easiest way to do it is to plug. So for the boundary, we can talk about more of this if you need to, but the boundary is the hard stuff, I think. So let's deal with that x squared plus y squared is equal to 3 just briefly. The way that I'm going to do this is I'm going to take f of xy, and I will substitute y squared. So I see that y squared. There's no need to write square root. I mean, I could. Here, I could do that. Let me just show you what I mean. Okay, so this would be the square root of 3 minus x squared. But you end up with this. Just make a direct substitution. That y squared there is 3 minus x squared. So that's just way easier. I mean, this is technically what we're doing, but just make that substitution. Then now you have an easy polynomial, 3x minus x cubed, and you can find the derivative. 3 minus, look at this. They were so kind to you. So x is plus or minus 1. Obviously, we aren't going to use the -1 because -1 would be over here somewhere on the curve. So the curve continues. So it's the +1 that you want. So I'm guessing it's +1 and the square root of 2. Is that right? I don't know. Whatever you get for y when you plug it in. I think it's the square root of 2. So, all right. So did you have further clarifications with this? I mean, I know I'm glossing over. I'm doing this kind of quickly. I want to make sure that we get to other stuff if need be. Okay, wow. Maybe my optimism was well founded. I still feel like there were too many problems here. I should have stopped here, but I didn't. Here's number 38. So here, this wasn't this was. I think that the deal with this one is it's not the shape. Did I mess up my shape? Okay, let's see. Okay, we're gonna check the shape. Okay, I didn't bother writing the points down. Let's do the points. Negative 2, 3, negative 2, up 3. So here, negative 2, 3. Over 2 and up 3. 2, 3. Over 2 and up 2 is this. And then negative 2, negative 2. Oh, it just makes it so much worse. I was going to say, this one's easy, even though it's lots of points, because, okay, negative 2, negative 2. Okay, so this one is even worse than I thought. Yeah, I definitely shouldn't have picked this. But that should go through the origin. I gave up now. Yeah, okay, well, so those three boundaries are easy. X equals 2, x equals negative 2, and y equals 3. Because even though there's lots of points here, because of the cubics, you're going to have potentially two critical points on each boundary. For example, when x equals 2, you end up with y cubed minus 12y, well, negative y cubed. Let's here just show you what I mean by this. X is equal to 2. You get f of 2y is a bunch of stuff. These are constants, minus y cubed plus 12y. And so f prime is negative 3y squared plus 12. Y is plus or minus 2. So you get a nice, easy plus or minus 2. I guess there's one, and there's one down here that isn't on that boundary. Same thing here. It'll be plus or minus 2. This boundary will be also simple. It'll have potentially two critical points. You can find them, plug y equals, I guess it'll be plus or minus 1. Okay, so that's a 1 and a negative 1. This one, not so nice. Okay, so let's deal with that one. Oh, wait a minute. Oh, it's not as bad as I thought. Oh, this one's not so bad. Okay, so there's not as many critical points. Here you go. Okay, let's do it. Here are all the critical points. Yeah, by the way, this is 1, negative 1, this is 1, x. Okay, so this, actually, this is so easy. Check it out. Y equals x. This is so nice. X, negative, and x, sorry, not negative. I got ahead of myself. So f of x, plug x and x into this, and we get x cubed minus 3x minus, it's actually even better than I thought. This is way easier than if it was a horizontal line. Okay, I don't feel so bad. Okay, that's just 9x, and f prime is 9. There are no critical points. Isn't that right? No critical points there because you have a constant, and it's just a constant 9x. So a linear function. So very nice. All right, so then it's not as bad. 1, 2, 3. There's only 9. 9 points you have to evaluate. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh yeah, and they're all integers. Okay, I don't feel as bad. I feel a little bad, but not as bad. Okay, so there's that. Any other questions about these? So that's what, I probably should have stopped it. I actually probably should have stopped it right here, but I did this one as well. So those 4, they weren't bad. Okay, good. Okay, let's get on to this stuff. Like I said, I probably should have stopped, but what was I thinking? Okay, well, I was thinking hopefully about what we would do on Wednesday, and those hopes were dashed apparently. So let's deal with these briefly. I don't want to do them completely. The worst one is number 49 probably. But let's take a look at 44 just quickly. Each one of these, you're supposed to come up with an expression for what you're optimizing. So it's just like this. We're finding maxes and mins, but you're not told what the function is. Actually, this closest to the origin, well, that's easy enough. We know distance formula. The distance formula is equal to the square root of x squared plus y squared plus z squared. That's the distance from the origin. And so let's just make a substitution here. Take that and shove it in there. And you have this for the distance. So the square root of x squared plus 9 plus xz plus z squared. So I want to minimize this function, and you have two variables. So I'll do the derivative of this with respect to x. I'll do the derivative of this with respect to z, set them both equal to 0, and then I can do it. So that one actually isn't terrible, but you could do this if you haven't done it already. Here's the function, minimize this. Find the minimum value of this. And by the way, you'll get one critical point when you do this. I know you're scared of that radical, but the radical ends up not mattering. Do the derivatives, you'll get a single critical point, and that critical point has to be a minimum because if you think about it, you have a surface and you want to know what's closest to the origin. You can certainly go really far from the origin. If there's only one critical point, it has to be a minimum. So there's no other work you have to do other than find that critical point. So there's your function. If you haven't done it already, you can certainly do it this weekend. Okay, next one. Find 3 positive numbers whose sum is 100 and whose product is a maximum. So this is what it's asking you for. X plus y plus z is 100, and I want this function to be a maximum. So maximize this. And so what we'll do is we'll do this. Let's see, sorry. Z is 100 minus x minus y. Plug this in here. And so here's the function that you want to maximize. So find the maximum value of xy times 100 minus x minus y. So you'll need to clean this up a bit. So if you haven't done it already, you can do it for Monday. All right. All right, one more. This one's the hardest because of, yeah, like I said, I think I was a little bit more optimistic last week than I should have been about what we would do. So we want to know largest rectangular box. So imagine a rectangular box in the x, y, z coordinate system. Here is the z axis. Here is the x axis. And here is the y-axis. So imagine this box sitting in the corner down there. And you might say, well, what is this whole business about one vertex? Well, the vertex has to be, so imagine this plane. So here, I will draw that plane as best I can. Hold on a sec. So let's see, it goes something like this. Okay, so you have to imagine that is kind of a plane that is floating out here. This triangle is, if you imagine that as a plane, that corner there is touching this plane. So that's what it's referring to. So if you weren't sure what to do, we want to find the volume of the largest box. So here's the way we would do this. You know volume is x times y times z. Just think of the sides of that box as being x, y, and z. That makes that coordinates of this point is the point x, y, z. And that point there, what's special about it is it will satisfy this. And so you know that that will be, so we could take this and we could say that, well, whatever box I have, the x coordinate of the box will be 6 minus 2 times the y coordinate minus 3 times the z coordinate. So my volume I could write as 6 minus 2y minus 3z times y times z. And I could rewrite that like this. 3yz squared. And I want to find the maximize this. So find your critical point and then go from there. Now, I guess I should say that x, you might say, well, what's the deal? X has to be between 0 and 6. We didn't have this with these two where there were constraints, but here your x value can't be any bigger than 6, because if you imagine sliding this point around this plane, it's never going to get bigger than 6. How do I know that? I guess when y and z are 0, x is 6. So that point there is 6. On the y coordinate, y can never be bigger than 3. Whoops, y can never be bigger than 3. And then the z coordinate can never be bigger than 2. So this is definitely not to scale. So z is always between 0 and 2. So you could use those as your region. Maximize that over that region. But I can tell you right now that if you use this point here for the corner of the box will have a volume of 0 because it will be a long flat box. In fact, any point along this line, you're going to have a long flat box. So just find the critical number. The critical number, or the critical point, will be the point to use for the volume. All right, so there's that in a nutshell. So this is what I failed to do last time, as we ran out of time. I should have shown you that you can take each one of these, and I probably shouldn't have had so many of them. Take each one of them, make them into a function of 2 variables, and then that gives you something to maximize or minimize. Wow. So do you have any other complaints, concerns, questions, what have you, about this? I did print up a quiz, but we're going to do it a little differently than we normally do, because this is a long process. It takes forever. It'll take you the rest of the period, possibly. Oh, you had a question?
Yeah, so when you boundary points, right? You after you find the derivative of the
which problem?
So like this in general.
Anyone in general.
Yeah,
so we find the derivative of this. Yeah, so I'll find the derivative.
Right, and then let's say you get x is equal to plus or minus 1.
Okay.
Like then you plug that back into the initial boundary equation.
Oh, on the boundaries, yes, to get the y coordinate.
So in the case where the boundary is like the points, you just like get the line equation essentially and put it into that.
Yeah, so like here, if you did this one up here, you would get, so this is this boundary. You would have f of, let's see, y is equal to 3 for that boundary. So x comma 3, which is x cubed minus 3x minus 27 plus 36. And those are just constants, so I really don't care about them when I do the derivative. So I'll get 3x minus squared minus 3, set that equal to 0. X is plus or minus 1. Okay, so that's what I get on this boundary. And then I'll take each of those and I'll plug them back into the boundary. And in this case, the boundary is just y equals 3. And so that's where this is the point -1, 3, and this is the point 1, 3. Yeah, very nice. Anything else? Okay, so quiz we're going to do a little differently. So this is a group quiz. So you can choose who's in your group. Now, if you really want to, you can move around, and because you might say, the person sitting next to me, that's not a good person to have in my group. Or maybe you want to, after you've worked with the person next to you for a little while, you might say, here's how you can do it. so that you don't make someone feel bad. Work with the person near you for a little bit, and then you could say, when you get done or near the end, you could say, you know what? Let's just check our work with that person over there, or like you pick. So you can move around and have a larger group if you want, and that will also help reduce the labor because you know how it is. You get to the point where you have this long list of critical points that you have to deal with, and who wants to do so many calculations on their calculator? If you divide up the labor, it will go much quicker. So let's go ahead and give this a try. Work with at least one other person, but after you work with one other person, you can move in another person, or you can work with a group of 5 if you want. However you want to do it is fine. Divide the labor. It's fine for you. No, I cannot be anyone because the groups have to be students in this class. So sorry. Although when we go on to do digital training, you have to play for all stars.
Yeah, after I just like sketch the ratios.
Okay, so this is stuff for me. Good. I'll put this up on the screen for the people who are watching it from home. There we go.
boundaries, or because I did that. I got one score. Oh, you did like run over, right? Yeah. Yeah, the right idea. Values of life. So I had like solved for 2 keys here, plugged it back in here. So you just have to plug this back in. So you get like the final value, yeah. To actually find the points, I just had to like do a bunch of reverse algebra. But so points I got were 0, 0, and -18s. Write this functions back. So.
Still trying to find the critical points.
Oh, very niche. I mean, I'm not entirely sure that this is right, obviously, but I saw for two. I'm like, I skipped one steps and everything. So it'd be like 9 just divided by 3 to get 2x. But directly back into here, we have 2x. B6 minus factor of y is 6 minus y. So y is 0 versus x is 7.
I didn't know the reverse because I started with this and then
Oh, okay. So you said like
I solved for x and this and then for integration.
I gotta make sure.
-3y or sorry, -3. Yeah. Solving for x.
Oh, I know.
No, not because shouldn't you actually multiply the key? Yeah.
Oh, I didn't know.
You get -6 plus y equals 0.
I have 6 times 3y
Oh, you put it back in the original function.
Yeah.
I think we're trying to find we're trying to find functions that satisfy both of these equations. So like you put it back into the other partial derivative. Oh, that's a reasonable. That's cool. I was gonna say like I'm not brave enough to do my math stuff in pen, but if it's a reasonable.
I like these.
Yeah.
And supervisor for my summer job actually helped me get it with like a college
Aw. Was the answer.
Oops. We're done.
Okay, so I equals 0, y equals 6.
Yeah. So like back into the equation that I solved for
Yeah, and you take the 24 plus 4 twice. Yeah, and then you set that equals 0, which has no real.
Well, it's the I'm doing this boundary right now, the one that's like an actual line. So
What is it? What? Put it in? Put it in X equals?
Yeah, it's gonna be so cheap.
Well, because it would just be 1, 2. You're right, because then
It's gonna be so much.
you won't have to expand that. Oh.
Yeah, it's gonna be bad.
We didn't get that far.
I didn't even get that. The last one.
I'm rearranging it. I'm rearranging it instead of that. It's slightly easier. I'm rearranging. I'm rearranging it in terms of x. I'm rearranging it in terms of x. X is negative 4y. Rearrange it in terms of x. It's negative 4y minus 1.
But we don't care about that.
Which I'm now going to see because it's plus y cubed. Yeah, that's actually much easier. Yeah, you just substitute negative 31 for x. And then you're only squaring it. You're only squaring negative 4y. Maybe. Oh, I don't have it.
Wait.
0.
Any of them? Well, that's what all this algebra is for. It's for this boundary. But I was like, oh, well, it's like, so this equals y. Let's plug in for y in the original function. Well, it led to this, but I think that is what you're supposed to do. But, okay, wait, what time is it? Oh boy.
Oh, is it time to go? Oh. Let's see.
Why can't they be nice to the first? I feel like we're why? Oh, it's going. It's like hi. He was like, are we sure?
So, let me try Play. I think next we're gonna try solving this for x and plugging that in here. Because like I was doing it for y, but it's an absolute fraction. Okay.
I did not write this. Let's just take it as small and go further. Three y squared plus y minus now we have to plug this y back into this. You got 5.2. Oh yeah, negative. What's it? Negative 14. Really? It's only one. You know what?
What?
It is now.
Yeah, it's shorter. We're just gonna
Because I'm realizing that we max out solving for y equations.
It's, yeah, horrible. Okay.
So I'm doing that.
All right, it's about 2 minutes to go here, so I want to make sure that you have time to get to chapel. I know everyone wants to go. I think it's communion today, is that right? So one of the things to note is that despite my best intentions, sometimes things go a little awry with my functions. And so in this case, the thing that went awry, I think, is the boundaries. It looked good until I got to the, so I'm done, by the way. I got it done. I used my computer to do the calculations. So when you get, well, I mean, just, it's like a calculator, okay? I have the function and I can just type in the, but I got some nasty decimals is what I'm saying on a couple of the boundaries, which made me depressed and disappointed. If you're not done, take this with you. That can be all that you have to do for your homework for Monday. And you can work with a group. This is good practice for me. Remember these quizzes, they are practice for the test. And this is good practice for me that I need to make sure that the test does not have a nightmare decimal on one of the boundaries. Otherwise, it'll take forever. So take this with you. I'll update the homework to say that you just have to do this for Monday. Okay. Where is my thing? There it is.
You're like,
Quiz. What is this? Quiz 21. Oh, there's a stack somewhere. I don't know. Find a stack. Quiz 21. Below. Come on. Save and return. It's on. Choose 21. Open location.
there's probably one number. Oh. The way I got it.
Where's quiz 21? Absolute maximum.